Hello students, hope you all will be well. In the previous lecture, we have discussed about the decomposition reaction. Now we are going to discuss about the third type of the reaction, that is the displacement reaction. Displacement reaction, that means the reaction in which highly reactive metal will displace the less reactive element from its salt solution. Okay, for this we have to perform this activity. Okay, in this case we will take three iron nails. Look here, there are the iron nails in a, look here, this is the, yeah, take 3 iron nails and clean them by rubbing with the sandpaper so that there should not be any dust or rust on that. Take 2 test tube marked as A and B. In each test tube, take about 10 milliliter of copper sulfate solution. Look here, in this case we will take 3 iron nails and we will clean them by sandpaper, and by taking the 2 test tube, one is labeled as A and other is labeled as B, and we will put copper sulfate solution in them. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution. Okay, just like this one, we will immerse the iron nails in the copper sulfate solution, and in the test tube B, and the coppers in the test tube B for 20 minutes. Keep one iron nail aside for comparison. We will keep third one iron nail for the comparison. Is there any change is there any change in the color of the nails which we have kept in the copper sulfate solution? After 20 minutes, take out the iron nails from the copper sulfate solution and compare the intensity of blue color of the copper sulfate solution in the test tube. Okay, also compare the color of the iron nails. Look here, this one, this was the iron nail that was in original position, and this is the iron nail that we have immersed in the copper sulfate solution. What happens to this iron nail? Why it has attained the brown color on its surface? Look here, why it has attained the brown color, and why the color of the copper sulfate solution fades? Why? What is the reason for the fading of the copper sulfate solution? This is because this reaction has taken place. Fe, iron nails, plus CuSO4 aqueous, means dissolved in water, that gives us FeSO4 plus Cu. Okay, copper is, that is the brown in color, and that will be get deposited on the iron nail. Okay, in this case we will come to know that iron is more reactive than the copper, so it has displaced copper from the copper sulfate solution. Okay, iron is more reactive than the copper, so it has displaced copper from the copper sulfate solution. So this will become, iron has displaced the copper from the copper sulfate solution, and it has come out, and it will take its place, and this will become FeSO4, and its color will be light green in color. So the color of the blue color of the solution, that will change into the light green color, and the iron nail which was originally gray in color, that will attain the coating of the brown layer, that will attain the coating of the brown color, and that will be of the copper. Is it okay? So in this case we have said that highly reactive element, a strong element, has displaced the less reactive element from its salt solution. So if for that, which element is very reactive, then which is less reactive? For this we have to learn about the reactivity series, and it is on page number 45 in your NCERT book, where the reactivity series has written that which element is more reactive than other. Okay, which one? That is a decreasing order. The elements written on the upper side, they are highly reactive, in the middle they are moderate reactive, and in the end they are the least reactive metals. Okay, for this you have to memorize that equation, that series. Otherwise you will also make this reaction. If I will write it, copper plus FeSO4, many students, 90% students, they will make that CuSO4 plus Fe, but this reaction does not occur because copper is less reactive than iron. So it will not, copper is less reactive than iron, and it will not displace, it will not be able to displace iron from the iron sulfate solution if I write it in reverse order. Okay, now another reaction of the displacement is this we call as a single displacement reaction. In this case, iron has displaced the copper from the copper sulfate solution. So this reaction is this displacement reaction. Similarly, if I take the zinc granules and put them in the copper sulfate solution, then it will form zinc sulfate plus copper. Okay, then the color will become from blue to colorless. Okay, keep it up, keep it in mind that ZnSO4 is colorless solution. It means the change has taken place from blue to the colorless solution, and the zinc granules will also attain the color of, that is the, they will also attain the brown color on the surface, and that brown color is due to the copper. Okay, because equation now will become Zn plus CuSO4 gives us ZnSO4 plus Cu, and zinc granules will attain the color brown color due to the formation of copper on the surface. Okay, similarly lead Pb plus CuCl2 copper chloride, this will give PbCl2, that is yellow in color, and plus Cu. Now the color will change from this CuCl2, this is also bluish in color. Okay, this will also change to the yellowish color. Okay, and this, in this case we will say that lead has replaced copper from its solution. So lead is more reactive than the copper, so it has displaced copper from the copper chloride solution. Okay, so in this case we have seen that the reactive element will displace the less reactive element or weak element from its salt solution. So this reaction is called the single displacement reaction. Okay, we can clarify it with the single displacement, because only one that stronger one has replaced the weaker element and takes its position. So it is called the single displacement reaction. Now next is the double displacement reaction. What do you mean by double displacement reaction? In this case we will take, just as we have taken this sodium sulfate, this is white color powder, we will dissolve it in water, it will get dissolved, colorless solution will be formed. Barium chloride, this is also white color powder, dissolve in water, this will also get dissolved in water and colorless solution will be formed. Now what will we do? We will mix both these solution in a beaker, or then we will see that white color precipitate will be formed. White color precipitate will be formed, and that white color precipitate are of barium sulfate. Now what has happened? In this case we say that the precipitate are formed and sodium has taken the position of the barium, and barium has taken the position of the sodium. Barium now comes with the sulfate and sodium comes with the chlorine. So they have exchanged their position. No one has replaced, okay, no one has taken another element out of the, but they have exchanged their position, and these are the ions. Okay, so we will say that in this case, in this double displacement reaction, ions exchange their position. So this is called the double displacement reaction. Okay, this is also known as the precipitation reaction. Now question is, what is precipitation reaction? The reaction in which precipitate are formed. What are the precipitate called? The insoluble substance formed after reaction. That are called the precipitate. Okay, the insoluble substance formed after reaction, they are called the precipitate. You should remember that in the starting of the chapter we have done the equation, that is lead nitrate plus potassium iodide, that gives us lead iodide plus potassium nitrate, and in that case yellow color precipitates are formed. Which color? Yellow color. That is also an example of double displacement reaction. That is also an example of double displacement reaction. That is also an example of precipitation reaction. Okay, so this was all about the double displacement reaction. Okay, because double displacement reaction, in this case precipitates are formed, so we can say that look here, this is the question that you can get in the board exams also. In this case lead nitrate when what happens when lead nitrate is mixed with the potassium iodide. Okay, and what was the color of the precipitate? The color of the precipitate will be yellow. Can you name that compound? That is PbI2. PbI2. Okay, now then you have to write the balanced equation, and also it is also a double displacement reaction. Which type of reaction is this? It is double displacement reaction. You will write PbNO3 twice plus Ki. Here you write 2 gives us PbI2 plus 2KNO3. Okay, this will be the equation for the double displacement reaction of lead nitrate. Okay, lead nitrate, right? So you have to write down in your book also. It will be easy for you to remember this. And here you can write, these are the arrow in the downward direction. Yellow precipitate will be formed. Okay, is it clear? In this case we have said that lead has taken the position of potassium and potassium has taken the position of lead, or we can say that nitrate has taken the position of iodine and iodine has taken the position of the nitrate. So it is called the double displacement reaction. Okay, so it is called the double displacement reaction, right? Now let us move further. This is the next kind, that is the oxidation reduction reaction or redox reaction. What is the color of copper? Color of copper is brown. In this case we have to take copper in a china dish. Only copper powder or copper chips we can take in the china dish, and we will start heating it. What will happen? The color of the brown color of the copper, that will change into black color. What has occurred? What has become? The surface of the copper powder becomes coated with the black, that is the copper oxide. Here Cu, 2Cu plus O2 gives us 2Cu. Now the question comes like, a brown colored substance when heated, then a black coating is formed on its surface. What is that black coating? This is because this is of copper oxide. Okay, this is the reaction. Now you can say that before the reaction copper was alone, after the reaction the copper oxide it has become. Now oxygen has added to copper, so this can be called as oxidation reaction. Oxidation means addition of oxygen. So we can say that in this copper, before the reaction copper was alone, after the reaction now oxygen has been added in this, so this is called the oxidation of copper. Okay, and the substance that we get, what was the color before the reaction? It was brown in color. After the reaction it will become black due to the formation of copper oxide. You can get 3 marks question like this. A brown colored substance when heated, it will change into the black color. What will be the equation? What is the formula of black colored substance formed? That is the copper oxide. Now if we pass the hydrogen over this copper oxide, if hydrogen gas is passed over the heated material copper oxide, the black coating on the surface turns brown again. Then again color changes from black to brown. It means the copper will be formed again. What will be the reaction then? Copper oxide plus hydrogen gives us copper plus water. Okay, this is also, as I have said you, that you can get the question like this. A brown colored substance when heated, it will form a black coating on its surface. What is that black coating? What will happen if we pass hydrogen over this black coated substance, and what will be the color that you will get again? So you will write that on passing that black color substance formed is the copper oxide. On passing hydrogen gas over the copper oxide, then it will form a black, it will again change into the brown color. What happens? Look here. Here it was copper oxide. Firstly it was copper oxide in this reaction. In the second reaction it was copper oxide, and when hydrogen is passed it will become Cu plus H2O. Now we can say that from the copper oxide oxygen has been removed, oxygen is removed, and hydrogen, before the reaction it was alone, and after the reaction it has gained oxygen. So we can say that it is oxidation reduction reaction or redox reaction. How? Because we have said that the addition of oxygen is called oxidation. This is changed into H2O. Okay, addition of oxygen, hydrogen, it was before reaction, after reaction it has become water. Now it means in the hydrogen oxygen is added, so it gets oxidized. And in case of copper oxide, copper oxide was having oxygen before the reaction, but after the reaction it will change into only copper. So it means what does it has lost oxygen. Addition of oxygen is called oxidation, and removal of oxygen is called reduction. Okay, removal of oxygen is called reduction. So we will say that copper oxide is reduced to copper and hydrogen is oxidized to water. Hydrogen is oxidized to water. Okay, so this type of the reaction in which oxidation reduction goes side by side, that are called redox reaction. Red word is taken from the reduction and ox word is taken from the oxidation, right? Okay, now you can also underline this. If a substance gains oxygen during a reaction, it is said to be oxidized, and if a substance loses oxygen during the reaction, then it is called to be reduced. Okay, and during this reaction, copper oxide is losing oxygen, so it is reduced. Hydrogen is gaining oxygen, so it is oxidized. Such reactions are called oxidation reduction reaction or redox reaction. Similarly, here are given the example ZnO plus C. In this case, zinc oxide, it will convert into zinc. It means it will lose oxygen, and carbon, before reaction it was alone, now it has changed into the carbon monoxide. It means it has gained oxygen. So carbon is oxidized. And zinc is reduced. Carbon is oxidized and zinc is reduced. Carbon is oxidized and zinc is reduced. Similarly, in this case, look here, what happens in MnO2 plus 4HCl gives us MnCl2 plus 2H2O plus Cl2. Now in this case, what will happen? Which one is getting reduced or which one is getting oxidized? You can get questions like this. You can have the equations. You have to mention that which is oxidized, which is reduced. Okay, from this we can say that in this reaction, HCl is oxidized to Cl2. HCl is oxidized to Cl2. Look here, HCl is oxidized to Cl2, and MnO2 is reduced to MnCl2. Okay, because from MnO2 oxygen is being reduced, it is expelled out, or it is going out, getting removed. The from which oxygen is getting removed, that is reduced. Okay, MnO2 will be reduced to MnCl2, and HCl will be oxidized. HCl will be oxidized to Cl2, because addition of oxygen or removal of hydrogen from HCl, hydrogen has been removed. From hydrogen HCl hydrogen has been removed, so it is called oxidized. Right, it is called HCl will be oxidized to Cl2, and MnO2 will be reduced to MnCl2. Okay, and in this case, now the question is that this is also oxidation reduction going side by side. Now here is also, when a magnesium ribbon burns with a dazzling white flame, we have written that magnesium plus oxygen, this gives us MgO. What do we say? That magnesium oxide, that is magnesium is getting oxidized. Because it will gain oxygen. Okay, and what will be which will be reduced? We can say that magnesium is getting oxidized and oxygen will be getting reduced. Okay, this was all about the oxidizing and reducing agent. Oxidizing and reducing agent, oxidation and reduction. Now what are the oxidizing and reducing agents? The substance that gives oxygen the substance that gives oxygen, which will be having itself oxygen, that we can give oxygen. Substance that gives oxygen, that is called the oxidizing agent, and the substance that takes oxygen, that is called the reducing agent. For example, look here, that is MnO2. It is having oxygen. MnO2 is having oxygen, so it can give oxygen, so it is the oxidizing agent. And HCl will gain that HCl, in this case we can that it will lose hydrogen, or itself will oxidized, so it is the reducing agent. Okay, it will be the reducing agent, right? That can give oxygen, that is the oxidizing agent, or that can take oxygen, that is the reducing agent. Okay, in this case in this way we have to mark in the equation what are the oxidizing agent, what are the reducing agent, which substance is oxidized into what, and which is getting reduced into what. Now next is the, have you observed the effects of oxidation? Have you observed the effects of oxidation reactions in everyday life? Corrosion, metals, the surface is getting dull along after some time. This means they are getting reacted with the gases or the water present in the air, so that is called the corrosion. You have seen that iron articles, they get rusted, and this process is called the rusting of iron. We can say corrosion of iron is given the special name, that is the corrosion of iron is given special name, that is called the rusting. Okay, some other metals also get tarnished in this manner. Other metals, just you have noticed the silver articles, they get black coating on it and the green coating on the surface of copper. That is also the example of the corrosion. Okay, now corrosion causes damage to the car bodies. You know that all these articles, these are made up of iron alloys, so these causes damage to the car bodies, bridges, iron railing, ships and all objects, and this is a very serious problem. So corrosion, that is because of this corrosion of the iron articles, the large amount of the money get wasted. Okay, and for you know that for corrosion, for corrosion of the iron, the water and oxygen, both things are required. In absence of any one, that will not be get rusted. Okay, we will further study what can we do. We can prevent the corrosion by painting, by oiling, by galvanization, by making alloys to prevent the rusting of iron. Okay, this was all about the corrosion, and we will further study in detail in the chapter 3. Okay, now what is rancidity? Rancidity means the taste and the smell of fat or oil containing food materials that get changed with the time. When fats and the oils are oxidized, because when the packets are opened and they are kept as it is without keeping them into the airtight container, this smell and the taste of the articles that are stored inside that packets, that get changed. This is called rancidity. Fats and the oils are oxidized, they become rancid and their smell and taste change. Usually substance, and we can say that the substance which prevents their oxidation are called antioxidants. This you can get the definition. What do you mean by antioxidants? Antioxidants, the substance which prevent oxidation, they are called the antioxidants, and these are added to the food containing fats and oils. You know that the chips manufacturer usually flush bags of chips with gas such as nitrogen to prevent the chips from the getting oxidized. If we keep the chips packets open in the air, then the smell and the taste of the chips will become bad. This is due to the oxidation. What is inside that packet? You know that packets are very, very fluffy, and they contain the gas, nitrogen gas, that prevent their oxidation. And when the packet is open, nitrogen gas flushed out, and then we have to keep them in the airtight container, or we have to tie the packet tightly. What are the other methods to prevent rancidity? How can we prevent rancidity? We can keep the food materials into the airtight container. Okay, how can we prevent? This is also very very important question. How can we prevent rancidity? By keeping in airtight container. Okay, by keeping in airtight container. Okay, and by using antioxidant, by keeping in airtight container, by using antioxidant, and by keeping the things that we can keep in the fridge, by refrigerating them, by using antioxidant and by refrigerating them. Okay, the things that can be kept in the freezer or that can be kept in the refrigerator, by refrigerating. Okay, these are the methods to prevent the rancidity. Okay, there are many chemicals that act as antioxidants. Nitrogen is antioxidant. BHA, butylated hydroxyanizole. BHT, butylated hydroxytoluene. These are the antioxidants that are added in the food items to prevent the oxidation. Okay, now this was all about the chapter 1, and I think you must have understood this, and try to learn in between, try to read NCERT lesson very very with very deep concentration, because the questions will be in between question you will get now. Okay, so take care now. Okay.